Let's start. Hello, good afternoon. Welcome to my talk about CDEs or Cloud Development Environment, and see how can they help us to improve cloud native application development, address some complexity. Before I start, let me introduce myself. My name is Saeed. I have been in the software industry for about 20 years. Right now, I'm working as a consultant in a consultancy firm based on Stockholm, Sweden, called OX, and also hold the position technology evangelist on that company. Besides that, I'm writing actively on Medium, technical articles about Java, Kubernetes, and Spring, this kind of stuff. Okay, let's start. If about 15 years ago, someone told you that after 15 years or maybe 10 years, you won't have any external hard disk in your backpack or in your home, and you will store all your personal files and photos on the cloud, maybe you have thought that he or she is crazy. But now almost all of us store our private file and photos on one of these cloud services. Yeah, the same goes for our source code. Source codes as a most valuable resources for companies. If you remember, maybe 20 years ago, 25 years ago, all companies has a private on-premise server that keep all the code. But right now, yeah, you can see some of these old Mercurial, CVS, and this kind of stuff. But right now, it's very, very normal. Bitbucket, not Bitbucket mostly, but GitHub, GitLab, almost all of them. And goes the same for our build servers, CI/CD, deployment pipeline. Do you know companies that has on-premise server? Almost, not all, but mostly migrate to the cloud providers. I would like to raise a question. How about the development environment, IDEs, and all related services that we as a developer need to start coding? If I say that in 2, 3, maybe 5 years, our IDEs and services that we need to start coding also move to the cloud infrastructure, would you believe me? Okay, one question. How many of you in this room have had any experience using CDs? Okay, only one. Actually, I started a poll in that application to see the result. 3 yes in different aspects, for real project, for personal project, and just for test. And as you can see, very similar to your situation, about 85% of attendees haven't had any experience about that. So let's start with this one. Have you seen this button in GitHub repository pages? Especially the middle one comes with code. Because for the others, Coder and Gitpods or other CDEs, you need to install browser extension. But GitHub, by default, integrated with a service, a CDEs called GitHub Codespaces. How many of you use that button, especially the middle one? Okay, so somehow you test CDEs. When I talk about CDEs, I mean the abbreviation is Cloud Development Environment, but in a better word means opening a project on the cloud for example, this cloud service called GitHub Codespaces. So let me show you for others that haven't had any experience. Yeah, this is the code button that I said. When I click here, if you want to continue development locally, you know, git clone, the famous command, HTTPS SSH, or Codespaces, you can create a Codespace by pressing this button, or I already created one. I press here to see what happened. Automatically my VS Code open. It's a Java project for one of my articles that shows the new feature in Spring Boot 3.4, the new integration with AssertJ in Mock MVC test API. It's a side sample for one of my articles. My default configuration is in Codespaces is to open, run the development environment on the Codespace cloud and open my VS Code at a thin client and connect it to that one. But you can change the configuration and open VS Code inside the browser. Or other IDEs, for example, IntelliJ IDEA, but IntelliJ cannot run inside the browser so far. Yeah, I wanted to show this one. You can see here inside the container all the project loaded here, and for example, if I go to this test, yeah, the language server start to building the code, and now I should be able to run all tests. I hope so. Yeah, or run some terminal command. It was a flash forward to what we'll see by the end of this talk, but this one is a very simple one. The question is, what happens if we want to open a cloud-native application using the CDEs? Because it is very simple. By pressing a button or something, just open a single repository inside the browser or your favorite IDE. But what will happen? Cloud-native application follows microservice architecture, several interconnected services, some shared services like database, message broker, and this kind of things. And yeah, we will see how can I use CDEs to both simple single repository project and also a streamlined development, complicated cloud-native application. But before I start, a brief history about what is cloud-native application. Yeah, in a very, very short term, a cloud-native application is an application that from the ground up, design and architecture and develop to take the advantage of the cloud infrastructure. Because before cloud computing era, we implement application, design and follow some architecture and deploy application on on-premise servers. After cloud native era, we try to migrate those applications to the cloud. We call those applications cloud non-native application because they designed for the previous cloud native cloud computing era. After a while, we found that we need some methodologies, factors, items. A group of developers from Heroku start publishing 12 factors that help us to implement cloud-native application that are scalable, maintainable, portable, and use all benefit of the cloud infrastructure. Then we found that we need some improvements, some update. So 15 factor comes in, as an extension to 12-factor. From now on, when I'm talking about cloud-native application, I'm talking about those cloud-native applications that we want to deploy on the Kubernetes as a platform and follow these factors. I have this one. Okay, before I start, I want to borrow two terms from this book, Developer Experience on Kubernetes, by Maurizio. Thank you, you are here, and also Thomas Vitale. They are writing this book about developer experience on Kubernetes, but we need these two terms, inner develop and outer develop. As you can see in the upper image, when we want to convert a requirement to a value, we have two main loops, inner develop and outer develop. Outer develop is related to the deployment pipeline, stages that we have, and this kind of thing. But inner develop is very important for us in this talk, talking about coding, testing, running, debugging, and as a loop. We as a developer do it every day on a daily basis. And eventually we convert the requirement to the feature. But what is the relation between these two, especially the inner develop to our talk? There are a lot of benefits to moving application to the cloud or implementing application in a cloud native way. The most important ones are at the end of the day, we want to have applications that easier to scale, that related to the outer develop, and also faster development loop related to the inner develop. For outer develop, we don't want to talk more about it, this part in this talk. We have invented a lot of more tools to address those complexity, because moving application to the cloud have brought us a lot of complexity. We need to invent CI/CD platform like GitHub Action, Argo CD, some packaging systems such as Helm, GitOps practices, observability, infrastructure as a code to make everything simple and reproducible, and so on. And these days, we know that almost everything is under control. To move our cloud-native application to the cloud, we invented some more tools that all of them are on the cloud. CI/CD, everything. And we leverage cloud benefits for the outer develop side. For inner develop side, for the sake of dev prod parity, one of the most important factor in 12-factor for us as a developer, we invented Minikube, Kind, and other piece of software that enable us to run local Kubernetes, single node Kubernetes, or multi-node Kubernetes locally. And also, again, we invented some more tools like Skaffold, Tilt, to make the process of building, packaging, creating Docker image, and deploying to that local Kubernetes cluster easier locally. And some more tools to address the complexity of the cloud-native application in the inner develop side. Okay, what was the result? We need more powerful hardware, because in order to run local Kubernetes, you need more RAM. And if your cloud-native application comprise of 10, or more microservices, you need more CPU cores and this kind of things. And also more complexity. We have our application complexity, those services, the local Kubernetes configuration, and tools like Skaffold, Tilt on top of them. A lot of complexities. The question is, did our development process really get faster when we decide to follow cloud native application development and move our application to the cloud in the development, inner develop side. I'm originally from Iran. In our language, in Persian language, we have a Persian proverb said, the potter drinks from the broken jar. Yeah, for sure, it's a literal translation. The closest conceptual one in English is the cobbler's children go barefoot. My question, let's get back to the question at the beginning of the talk. We help everyone in the software industry to move their services to the cloud from those file and picture and those services like OneDrive, G Drive to, I don't know, AWS services and CI/CD services. We help everyone, but the cobbler children go barefoot. But we, as a developer, highly rely on our development machine. Every other years, or I don't know, we need to increase, we renew our laptop with a better CPU and this kind of things. You know better than me. Why not? Why not we move our development environment entirely to the cloud and just by a thin client, such as this MacBook Pro, MacBook Air, or other thing, just connect to the cloud, connect to your development environment, and start coding from everywhere. This kind of concept for you as a developer is not new. I'm sure that some of you in this room use Vagrant in the past or NixOS these days to, I don't know, rent a remote machine and somehow offload some load from your local machine to somewhere. For example, those heavyweight Kubernetes cluster or something like this. But what is the difference between Vagrant or Nix OS with cloud development environment, or what is it? In short, cloud development environment fusing all these best practices and proven concepts like remote development using SSH, IDE, running language servers on the remote machine instead of my local machine, and infrastructure as a code, run some of our dependencies on a VM remotely, and cloud infrastructure. The main difference between those approaches that you might try with the cloud development environment is that some services, some platform like GitHub Codespace that you saw, and some other like DevPods, Gitpods, provide or fusing this concept together as a service and provide us to enable us to move our entire development environment to the cloud. We will see how. Benefit of CDEs. The first one, and for me the most important one, is the consistency and repeatability or reproducibility. When you start to define your development environment as a code, very similar to infrastructure as a code, that right now all of us knows about the benefits. You can easily reproduce your infrastructure when you define your application infrastructure as a code. Very similar here. When you define as a developer, as a team lead, for example, your development environment as a code, then you can easily commit and push those codes to the GitHub, for example, and your coworker or your new team member can use it to create the development environment. Right now, we have a README file or a wiki page in our Confluence in our team. And when a new member joins us, okay, we need to assign a developer in our team to that developer and step by step manually run those aspects. The next one is Flexibility and scalability. Okay, we want to move our development environment on the cloud. It's obvious. Cloud infrastructure benefit is flexibility and scalability. This is very important. You will see. I will connect to my home server at home when we want to run some example with a very tiny MacBook Air and run cloud native application that inherently are heavy. So code from everywhere is another important benefit. Faster onboarding for new developer. These two are supplementary, as I mentioned. Simplify environment management at the company level, big company level. You can share easily between development environments, some share configuration, and those configuration can be some security related things. When you move your development environment on the cloud, you can have a better control, security-wise, I mean, and also some backup system and this kind of thing. Another benefit that related to the portability and code from everywhere is seamless collaboration. You as a developer, since your development environment is on the cloud, you can share with your coworker. And cost, maybe, to my experience, it depends to your project, the size of project, and yeah, it can be in the future one benefit. Yeah, let's talk about CDEs a little bit in detail. If we want to categorize CDEs architecture and main component, I could categorize them in 6 categories. The first one and the most important one is IDE, or a browser as a client, since the idea is that you want to offload all the complexity and resource-intensive things to somewhere else on the cloud. So you need to have an IDE or something that you can start coding. Yeah, JetBrains introduced JetBrains Gateway that supports most famous CDEs in the market. You can connect to your development environment on the remote machine and start coding. But the leader in this area is VS Code, and all VS Code-based IDEs like Cursor and Windsurf. In comparison to JetBrains IDE, VS Code is very fast and very lightweight, and its support is very wider range. I mean the CDEs in the market. We will see. The protocol, yeah, the de facto protocol in this area is SSH, but it can be something else. Remote development tool deals these days by language server protocol. Things get much easier than before. You can easily move all code IntelliSense, everything that we need as a developer inside the IDE to the remote machine. Debugger and everything, we had it before. It's not a new thing. But the most important one, the remote machine. The remote machine can be a VM, but containers are so fast. It depends on the CDE that you choose. It can be a VM or container, or even a Kubernetes cluster, a container inside a pod. Because some companies at the beginning especially said that, okay, we have a Kubernetes cluster, for example, define a new namespace for our development environment and use it. There are some problems. We will discuss about it. And hybrid approach. Right now, the hybrid approach for remote machine and architecture is the most popular one among CDEs. Another important part is development environment as a code, as an extension to the environment. Infrastructure as a code. There are some standard in the market. Dev container is the famous one. Dev file from Red Hat. Nix or Nix language from the Linux community. And some CDEs use Terraform, mix between Terraform, for example, and dev container, we will see. And architecture-wise, some CDEs has orchestrator, and some, especially the new ones, implement the concept without orchestrator. What does that mean? For example, if you want to create your development environment on the Kubernetes, okay, you can reuse Kubernetes orchestrator. But if you want to distribute development environment inside some virtual machine, you need an orchestrator to orchestrate, find the machine with free resources, and then create your environment. In this talk, we will use GitHub Codespaces that we used at the beginning, and also DevPod. DevPod position itself as an open source alternative for GitHub Codespaces. GitHub Codespace uses hybrid architecture. What does that mean? When you click on that code button and open a GitHub repository inside the Codespaces, GitHub Codespaces create a virtual machine for you, and then inside of that virtual machine, start to create container for each repository that you want to create a development environment for that. And then you can see the communication. But DevPod took a different approach and work without orchestrator and the client only. It means every developer install a client on their machine, a very tiny client, and then, as you can see, there are several providers: Kubernetes provider, AWS provider, GCP provider, remote SSH machine provider. We will see in the DevPod, and then developer decide to create a development machine. Other than these two, we have a lot more Codespaces in the market. Gitpod is the other one. But in the past, Gitpod Classic used Kubernetes as an orchestrator. I think last year they decided to move from Kubernetes and choose the client-only architecture similar to DevPod, because they publish a blog post in their technical blog. You can read if you are interested. But the short summary is that they found that the workload that user create for a cloud-native application is totally different from the workload that we as a developer produce for the Kubernetes. If we want to use the same infrastructure for these two different workloads, it doesn't work. For example, one developer creates several development environment, and its development environment are so heavy. A typical problem called noisy neighbor happen in these scenarios. And okay, let's see these things in practice. I clone this book examples. Actually, 4 years ago, 3 years ago, here at Barcelona, I met Thomas Vitale. At that time, he was writing Cloud Native Spring in Action, very similar to the previous book that I mentioned. At that time, this book was in the MIP, in the Manning publication, but right now it's released. I love this approach by Manning. You can pre-buy the book, but the book is not ready. You can follow writer or writers, chapter by chapter. Manning inform you this chapter is ready. At that time, this book, I pre-bought this book, and it was very good for me. I cloned the project because there is a very good cloud native application in this book. Um, but I changed it and add some configuration to it, and we want to use DevPod. Let me show you first. Yeah, this is the project that I cloned. As you can see, it is about a bookshop, online bookshop called Polar. There is a catalog service, config repository. This is a Spring Boot config server, and yeah, this is config server, and this is config repository. Dispatcher service for communicating with message brokers, because this project is very good. Has database, message broker. The edge service somehow is the front service for communicating with outside. Order service, and the platform is the share infrastructure that we as a developer need to create. Okay, as I said, DevPod as an open source alternative for code spaces follow the client-only architecture. What does that mean? We have a client here, and there are a lot of provider, Kubernetes provider, SSH machine provider, multipass. If your company or you have a AWS virtual machine, there are a lot of different providers that you can connect it to the DevPod. Actually, I have an old laptop at home. I install an Ubuntu server on it and then connect it here. And I use Tailscale as a VPN or something like this to connect my internal home server, to make my internal home server accessible from outside. And here you can create your workspace. When you press on the create button, you can start with a local folder or a GitHub repository, or even start with a VM. I did it before, and yeah, this is this example comes from chapter 11 from the book. I can open this project with almost all browser. DevPod support all major browser in the market. For now, I'm gonna use IntelliJ, but for the next example, we migrate to VS Code. IntelliJ is so slow and support remote development and dev container very badly, flaky, buggy. But beforehand, I open everything, cache, and let's see, can it open it or not? In this talk, as a development environment, as a code, as a standard, we mostly talk about dev container. Dev container is a standard that you can define your development environment as a code. Similar to, for example, Terraform, that we define our production infrastructure as a code. Yeah. Okay, as you can see here, my IntelliJ just consumed 1 GB of RAM for this huge project. A lot of microservices here, and we don't want to dig into each service, but my laptop acts as a thin client, just communicate with the server, everything from language server, but VS Code doesn't use language server for Java language. This is the problem actually. VS Code run a headless IntelliJ version inside. It's stupid, I know, but they do, and then connect this client to that headless IDE. For Java project, it can be very costly, because if you use cloud infrastructure, they need to pay a lot for memory and this kind of thing. But I just want to show you. And yeah, all of our configuration is here into the dev container JSON. As you can see, there is a base image here. The project is based on Java 17, so I use this image and then install some feature. For example, we want to use Gradle because this project from the book is based on Gradle. And also we want Docker daemon because we want to run local Kubernetes cluster inside the container, and some configuration. We want Minikube. If you read that book, you know that all the book use Minikube as a local Kubernetes. And also Tilt. Now everything is up and running. If I first, with this script we can create a Minikube instance and then continue. Let me run it. Create. Okay, it is already exist, and so I can run tilt up. And tilt is a tools that help us for develop cloud native application much easier locally. Okay. And there is a port forwarding feature, both VS Code and JetBrains ID follow it. Since everything run on my local, my home server, I need to port forward here. Yeah, after port forwarding, I can open it. What is the tilt port? Yeah, this one. I need to forward this port, and then it is trying to run. These services are running. Keycloak as a authentication server, Postgres, Redis, RabbitMQ, Polar UI, and everything. And here in the JetBrains ID, you can see my home server configuration. Right now, it's an old laptop with 16 GB of RAM. This is the configuration. Okay, let's continue. Yeah, as we discussed, we have the concept development environment as a code now, as an extension for infrastructure as a code and environment as a code. Because after infrastructure as a code, we found that, okay, it's a very good things that we can declare our production environment. So it's much better to use it for our staging environment. I said that we have a lot of standard for development environment as a code. Dev container is somehow de facto the most important one in the market. Code spaces, dev space, and 3 more CDEs that I listed support dev container. Dev container is a standard for defining development environment as a code by Microsoft, and at the beginning it designed for introduced as a standard for GitHub Codespace and VS Code, but other IDEs like JetBrains and other CDEs like DevPod that you saw start to adopt with this standard. You can see a sample I show you in the IntelliJ also. We need to have a base image. All of our development environment will create inside that image. I mean the Docker image for sure. But dev container also support raw Docker file, and it's a very good feature. You can write your Docker file if your development environment is a bit complicated, and also support Docker Compose. If you have a lot of shared services or your project already has a Docker Compose. And two encapsulation concept, to the most important one, feature and template. You saw feature in the Polar Bookshop example, and with these two encapsulation mechanism, we can add capability to our development environment. For example, Docker daemon, Java version, Python, everything, Node.js, everything that we need. And you can see here. There are also some more specification. For example, customization. If your project need a specific IDE setting, for example, for code formatting or something like this, or one or more IDE extension or plugin, you can define it in this way in the customization section. And also lifecycle hook can be very useful if you want to run some script exactly after or during or in some time when your development environment want to create. Okay, now we want to talk about multi-repository service or cloud native application. In our previous example, we saw that the Polar Bookshop, all the microservices was in one repository. But for a real project, we have a dedicated repository for each services. And we as a developer start to clone one of those and start coding. The first thing that I found that we don't need to restructure our project because of the dev container or any development environment as a code. We keep our project as is and then start to adopt development environment as a code standard, in our case, a dev container to our project. There are some patterns that I want to mention. For example, for this application, this is very similar to the Polar application. We have one dev container folder. It can apply for other standards, but we are talking about dev container. We have one dev container folder, and all dependencies that we need defined inside just one dev container file. This project and the Polar Bookshop follow this pattern. The next thing that I want to open this project, Bank of Anthos. It's an example from Google team. It's a multi-repository project. As you can see, we have one parent dev container that contain all shared services and requirements for our development environment. But each microservice also has its dev container file. What does that mean? It means if we want to only start developing with transaction history, we can clone that project and open it inside the dev container. But before that, we need to clone the whole project. For example, we can use Git submodule feature and connect one parent repository to all independent Git repository for each services. And then start by cloning the parent project. And yeah, do you know about Git submodule? Then you can just update or fetch each module that you need. Another approach is that have one dev container folder in a parent project, and inside that dev container have one dedicated dev container for each project. For example, this project comprises of a Node service and Python service. Instead of having dev container file inside of these two projects, we can have everything inside the one dev container folder and then subfolder. In this approach, we can have a dedicated repository for dev container configuration. It is very similar to GitOps concept. Usually, we have a dedicated repository for GitOps things, and then one repository for each services. Okay, this is very similar to that approach. We have one dedicated repository for dev container configuration for all of our services, one dedicated folder for each services, and then we clone the dev container parent folder and other project beside that. This is Bank of Anthos as our last example. It's a somehow complicated project implemented using Python. You can find it in Google example official repository or something. It's a bit old example for 3 years ago, but it was very good for our things. This time I'm gonna open it, but again I cloned this project in my GitHub repository and adopt it with the dev container, because as I said, we don't want to change the project infrastructure for development environment as a code. The project, I haven't changed any code in this project. I just adopted it. Yeah, we can see a Bank of Anthos, but this time I'm gonna open it with VS Code. This project follows Git submodule. We have the second approach, the second pattern that I mentioned. Yeah. As you can see, this S in VS Code means this is a submodule. The real GitHub repository isn't here. It's just a link to that one. Okay, let's see. For example, the transaction history, it is based on Java 70, and we use Docker in Docker feature because we need Docker. The project uses a Skaffold. The previous one used Tilt, but this one uses a Skaffold. We need Docker daemon. We use Docker in Docker, and yeah, Java 70. But there is another microservices here, yeah, balance reader. It is based on Java 8. In this approach, you can have even project in Python language, Node.js, Golang. Even you can have two Java project that has different requirement in Java language, and you can easily check out the container and go inside the container, start developing with this configuration here. That container has Java 70, and then go to the other one. But it's a very complicated project, and the configuration is a bit complicated. We are somehow out of time, so okay. Similar to everything, there are benefits and limitations. We talk about all benefits, but about limitation. Network accessibility, of course, because your development environment is on the cloud or somewhere remote. Network latency also is very important. Right now, we have IDE limitation. For example, that Bank of Anthos example that I showed you, if you want, you can stay. I can show you. You need to do some trick, according to my experience. If you want to access to one microservice inside the container, because almost none of CDEs in the market support this feature. But it's an open question. You know, this is an open opportunity for all companies that start to investigate on this. And it's a very rapid area, actually. Mobile development, the only CDEs in the market right now that support mobile and web development is from Google, called, in the past it's called Project IDX, but right now Project IDX merged with Firebase Studio. Last month Google announced support Android development and also web development on the cloud. You don't need to run emulator and this kind of thing. It's very exciting. And also data privacy and security concern and cost. Okay, question. We have some minutes if you have any question. Okay. But at the end, as I said, it's a totally new era, moving all development environment to the cloud. But I believe that it is an inevitable change. It will happen. It will happen sooner and later. You hire by a company that give you a lightweight laptop or an old laptop and said that, okay, this is your username, password, you can connect to our cloud development environment. But I believe that it's an open question. If you want to start a startup or something, this area is very good, especially for cloud native application, microservices with multiple. So you can, right now, as you see, I merged several concepts. GitHub module, I don't know, Docker in Docker or Docker outside Docker, shared registry, because all of these microservices need to build image, deploy to somewhere. I know that these guys in their book working on the Nix side recently. It's an open question. I don't know, maybe he confirmed. It's an open question, and but a bright future, I believe. Yeah, thank you.